लाइव है। हेलो स्टूडेंट्स, वेलकम टू द सेशन। थोड़ा लेट हो गया, हमारे स्टार्ट करने में थोड़ा टेक्निकल इशू आ रहा था, कोई बात नहीं, सेशन स्टार्ट हो गया है। हेलो जयदीप, वेलकम टू द सेशन। तो आज के टॉपिक्स होने वाले हैं एनएलएम, रोटेशनल मैकेनिक्स और वर्क पावर एनर्जी भी है इसके साथ। यहाँ पे सिर्फ रोटेशनल मैकेनिक्स और एनएलएम लिखा है, लेकिन वर्क पावर एनर्जी भी हम लोग इसी में पढ़ेंगे। अब बिफोर वी गेट स्टार्टेड, what is important about this section is this covers a major part of your class 11 section। तो तुम्हारे मैकेनिक्स के दो पार्ट्स होते हैं। मैकेनिक्स का पहला पार्ट होता है ये तीन, वर्क पावर एनर्जी, न्यूटन्स लॉज ऑफ मोशन और रोटेशनल मैकेनिक्स। और मैकेनिक्स का दूसरा पार्ट हो जाता है योर फ्लूइड मैकेनिक्स चला गया, ग्रेविटेशन चला गया, दोज थिंग्स। तो ये जो फर्स्ट पार्ट है, इवन ग्रेविटेशन को भी समझ लो टू एन एक्सटेंट इन हियर। तो ये जो फर्स्ट पार्ट ऑफ मैकेनिक्स है, दैट हैज द हाईएस्ट वेटेज। ये मैकेनिक्स 1 जिसको बोलते हैं, दैट हैज द हाईएस्ट वेटेज इन योर जेईई। मतलब सबसे हाईएस्ट वेटेज दो सेक्शंस के होते हैं, एक मैकेनिक्स 1 और दूसरा होता है तुम्हारा इलेक्ट्रोमैग्नेटिज्म। सेंटर ऑफ मास इंक्लूडेड। हाँ, सेंटर ऑफ मास के भी एक दो करेंगे जयदीप, देयर वुड बी अ सेंटर ऑफ मास क्वेश्चन एज वेल इन हियर। ओके, collision, center of mass, everything. Fine, so this is the major section of your mechanics part. So we'll get started. There's some different varied level questions, अलग-अलग एकदम cliched questions नहीं रखे हैं. There is a bit of variations as well with regards to the question. So as we go about with this, you will get to know about it. So let's get started with the session. The rate of mass of a gas emitted from the rear of a rocket is initially 0.1 kg per second. If the speed of the gas relative to the rocket is 50 meters per second and mass of the rocket is 2 kg, then the acceleration of the rocket in meters per second square is. तो यहाँ पे simple rocket propulsion का formula है. If you don't remember or don't know the rocket propulsion formula एकदम simple है. It's given by F, or rather the thrust, FTH. Thrust is equal to dm dt into urel. urel मतलब है relative velocity between the rocket and the जो भी गैस या जो भी गैसेज है उसको निकाल रहा है। तो यहाँ पे dm dt is already given to us as 0.1 kg second, और जो relative velocity है वो भी दिया हुआ है as 50 meters per second. So I can get the thrust as 0.1 into 50. 0.1 into 50 वो मेरे को देता है 5 newtons of force. After that it is said that the mass of the rocket is 2 kg. तो इसके बाद that's simple, since force is this, acceleration, this is force, so acceleration is just force by mass. तो 5 divided by 2 करोगे, you'll get 2.5. Okay, answer is 2.5. That's right Jaydeep. Let's move on to the next question. A mass m is suspended by a massless spring wound around a uniform hollow cylinder of mass m and radius r. If the string does not slip on the cylinder, then what acceleration will the mass release? तो यहाँ पे तुम्हारा Newton's laws of motion combines with rotational mechanics. तो पहले free body diagram draw कर लेते हैं. Free body diagram में यहीं पे मैं कर ले रहा हूँ. Down here you have the acceleration of, you have the force of mg, gravitational force. ये चलो एक acceleration a से नीचे आ रहा है, तो यहाँ पे the tension would be T. So for this I can write the equation as mg minus T is equal to ma. ये हो गया इसका equation. अब what happens with regards to the pulley? Pulley is not a light massless pulley. It has a mass and a radius r. अब जो tension है, that tension is acting tangentially along the pulley and that is what will make the pulley turn. तो ये जो टेंशन फोर्स है वही हो जा रहा है योर टॉर्क. दैट इज व्हाट इज गोइंग टू गिव यू टॉर्क, एंड द टॉर्क वुड बी T into R, बिकॉज फोर्स इनटू द डिस्टेंस, इनटू द रेडियल डिस्टेंस, TR, क्योंकि वही घुमा रहा है, दैट इज इक्वल टू I alpha. I is the moment of inertia of this pulley and alpha is the angular acceleration. Because it is not slipping, I also know that alpha is equal to A by R. Alpha is equal to A by R, which means from here I get T, since I need to solve for A, T is equal to IA by R square. IA by R square I हो जाता है क्योंकि it's a pulley. Pulley मतलब इसका डिस्क है essentially, whose moment of inertia is mr square by 2. Okay? अच्छा, सिलेंडर है, hollow cylinder मतलब it's just mr square. ठीक है, तो I अगर mr स्क्वायर लगाते हैं, mr स्क्वायर इंटू a बाई आर स्क्वायर करते हैं, तो इसको हटाओ, यू गेट ma. m into a. T is equal to m into a. Now we can put that in this equation over here. और वो लगाते ही चलो इसका कहाँ पे लिखें, इसका सेक्शन अलग कर लेते हैं. So over here if you put T is equal to ma, you will get mg is equal to ma को उधर जाएगा तो it will become 2ma. So mm cancels, a is equal to g by 2. So our correct option is option B. Answer 2g by 3. No Jaideep, it's g by 2. Just see where you made a mistake over here. कहीं पे कुछ गड़बड़ हो गया हो सकता है. Okay? Let me know Jaideep if you got this correctly or not, या कुछ doubt है इसमें. Fine, let's move on to the next part. Here it says, I think Jaideep what you did is you used mr square by 2. Because if you use mr square by 2 तब जाके you would get here. You used mr square by 2, right? Yes, right. तो जो भी है यहाँ पे it says a 40 kg slab rests on a frictionless floor as shown in the figure. A 10 kg block rests on top of the slab. The static coefficient of friction between the block and the slab is 0.6 while the coefficient of kinetic friction is 0.4. 10 kg block is acted upon by a horizontal force of 100 Newton. If G is 9.8, the resulting acceleration of the slab will be. So first off, I'm applying the 100 Newton on the top slab. उसके ऊपर यू कैन अंडरस्टैंड कि 100 न्यूटन का नीचे जो वेट होगा, जो नॉर्मल रिएक्शन होगा, दैट वुड बी 100 न्यूटन्स 10 into 10. जी को 9.8 मत लो, ठीक है. दिस इज अ क्विक ट्रिक आई एम टेलिंग यू विथ रिगार्ड्स टू योर JEE competitive things. Even if they say 9.8, no, don't work with 9.8 unless you see variables like कोई 19.6 दिख रहा है या 49 दिख रहा है. If you see numbers like 19.6 and 49, only then take G 9.8 because then they would cancel out. Otherwise, for all intents and purposes, deal with G as 10 meters per second square. End में थोड़ा बहुत approximation कर ले सकते हो, ठीक है. So we'll deal with it as 10 meters per second square for now. जुगाड़ लगाओ थोड़ा यहाँ पे. तो the maximum normal reaction would be 100 Newton. And क्योंकि force यहाँ 100 Newton लग रहा है, you can be pretty sure that the frictional force, static friction force can take a maximum value of 60 Newton. Fs, the maximum static friction would have been 60 Newton. अब क्योंकि तुम उससे ज्यादा फोर्स लगा रहे हो, you are sure कि this will move. Moving मतलब you now have kinetic friction. तो kinetic friction का वैल्यू क्या होगा? Fk would be equal to kinetic friction coefficient into that 100 Newton, which would be 40 Newtons. अब 40 Newton force is acting on this body. So if I draw it in 2D from the side view, let's draw it over here. From the side view, if I draw the two bodies, the two slabs, इसके ऊपर ये 40 Newton force इस direction में act कर रहा है. There's 100 Newton on this side and 40 Newton is the friction force on that side. This 40 Newton is exerted by this block, let's call it 1. So this 40 Newton is by block 1 on the block 2. But by the Newton's third law, ये block 2 भी इसके ऊपर exactly opposite force लगाएगा, which would be 40 Newton on this side. This 40 Newton is acting on this side on the lower block over here. That is the only force acting on the lower block, मतलब in this direction. So that is the only thing that will bring about the acceleration. So what would be the acceleration over there? You would have it as कहाँ है mass कहाँ है 40 kg slab rest. Okay, 40 kg. So mass is 40 kg. Force is this. So A is equal to F by m. That is 40 Newton divided by 40 kg. That is 1 meters per second square. क्योंकि वहाँ पे 9.8 था, so it is 0.98 meters per second square. देखो, I could approximate 9.8 को 10 क्योंकि all other options are too far away. Okay, everyone is got this down, clear? The people who are responding, Jaideep, is this correct? Did you get the correct answer? चलो move on करते, क्योंकि ये वाला बहुत students को they get confused कि what would be the force on this if it starts moving. Just get the kinetic friction force. It's the exact same force on the other body as well. Moving on, it says a satellite in a force-free space stationary interplanetary dust at a rate of dm/dt is equal to alpha v. The acceleration of the satellite is simple सा relation है, same relation we'll use as for the rocket propulsion. Because just like rocket propulsion, यहाँ पे भी this is the case of the variable mass. So वहाँ पे भी force was equal to the relative velocity v into dm/dt. अभी dm dt का वैल्यू यहाँ दिया हुआ है अल्फा v, सो f इज इक्वल टू अल्फा v स्क्वायर and f is we need the acceleration, so acceleration is equal to the force divided by the mass, so alpha v square divided by m. So our correct answer is this one. It's minus because here it is slowing it down. तुम्हारा जब रॉकेट propulsion होता है तो the mass that is released out that speeds up the rocket. लेकिन यहाँ पे because the satellite is going, it's like suppose तुम्हारा एक डंडा है, ऐसे तुम घुमा रहे हो, झाड़ू लगा रहे हो और झाड़ू लगाते लगाते तुम्हारा डस्ट पाइल अप कर रहा है. Because that dust is piling up or that जो भी है whatever you're cleaning that's piling up, the mass is increasing of this and that is why you can understand it's going to slow it down. So acceleration negative होगा यहाँ पे. That is why it is minus a है, ये जो भी alpha होगा ये minus alpha v square divided by m. Okay, चलो next question. A monkey is descending from the branch of, ये वो famous H.C. वर्मा question है, descending from, अच्छा नहीं ये तो पेड़ से उतर रहा है. H.C. वर्मा क्वेश्चन इज क्या कहते हैं, बंदर से बंदर लटकता है. Anyway, branch of a tree with constant acceleration, if the braking strength is 75% of the weight of the monkey, the minimum acceleration with which the monkey can slide down without breaking the branches. बहुत spelling mistakes है, but it's simple. तुम अगर free body diagram draw करते हो, this is the monkey, we'll treat it as a block mass over here. This is the tension with which the rope keeps him up. He might be accelerating down, but there's still the rope which is supporting him to an extent. नीचे कौन खींच रहा है? नीचे mg. His own weight is what is taking him down, and his acceleration is downward, and that is what we need to find. A. तो इसका अगर लिखते हैं हम लोग तो we'll write the equation as mg minus t is equal to ma. Now this t, the maximum value that this t can handle is 75% of the weight of the monkey. So 75% of weight of monkey is mg. So t is equal to 75% of mg. So mg minus 3 mg by 4. 75% is 3 by 4. That is equal to ma. m's को हटाओ यहाँ पे, g minus 3g by 4. You'll get a is equal to g by 4. Okay. सिंपल, यहाँ पे ज़्यादा कुछ ये का नहीं है. ठीक है. अगेन any of you get stuck, let me know, I'll come back and do this question, but ज़्यादा don't let the questions pass by a lot because then it will be difficult to come back. Anyway, next question. A plank with a box on it at one end is gradually raised about the other end. As the angle of inclination with the horizontal reaches 30 degree, the box starts to slip and slides 4 meters down the plank in 4 seconds. The coefficients of static and kinetic friction between the box and the plank will be respectively. तो यहाँ पे first thing, when I'm lifting it, we have that angle of repose जो कहते हैं. When we lift it, it's at 30 degree, it starts sliding. And we know mu s, the static friction coefficient, mu s is equal to tan of theta, or in this case tan of 30 degree. So mu s is equal to 1 by root 3. ठीक है, it's equal to 1 by root 3. So we have the options given. अभी देखो, I'll show you the full method also, but I'll also show you the जुगाड़ method over here. Okay? पहले तो full method देखते हैं. So 1 by root 3 क्या देगा? 1 by 1.732 ऐसा कुछ देगा. So over here let's assume that here let's make it 100. इसको यहाँ पे और ऊपर नीचे 100 मल्टीप्लाई करते हैं तो 100 डिवाइडेड बाई 17 into 6 is 102. ठीक है, ये up till 19 up till 20 tables याद रखना. 17 into 6 is 102. So I can tell that ये roughly 6 के around जाता है. तो यहाँ से I will be getting, ये 1.7 था तो technically 60 पे जाएगा, which will roughly make this as 0.6. ठीक है, mu s is 0.6. Next we need to find mu k. अब mu k के लिए क्या मेथड लगाएंगे हम लोग? mu k के लिए when it starts sliding down even at 30 degree, जैसे ये मूव करना स्टार्ट हुआ, it shifts from static friction to kinetic friction. That is why now the friction value will be reduced and then it will slide down. तो even at 30 degree हम लोग का equation क्या होगा? In this direction you would be having mg sin theta. In this direction you would be having mu k mg cos theta. And over here you have the acceleration a. Right? What is the acceleration going to be? The acceleration is 4 meters in 4 seconds. So we'll use the relation S is equal to half AT square. UT plus half AT square होता है starting from rest, तो U 0 हो गया, which makes A is equal to 2S by T square. S का वैल्यू भी है 4, उसका वैल्यू भी है 4, so 2 into 4 divided by 4 into 4, हटाओ इसको, यहाँ से 2 जाएगा, so acceleration is half meters per second square. यूनिट अभी भूल जाओ. तो next thing we need the kinetic friction. अभी हम लोग इसका इक्वेशन लिख सकते हैं. The equation would be mg sin theta minus mu k mg cos theta is equal to ma. ठीक है. फर्स्ट मासेस हटाओ यहां से. You will be getting a is मेरे को mu k चाहिए, राइट? mu k is equal to g sin theta minus a divided by g cos theta. क्योंकि थीटा इज इक्वल टू 30 डिग्री, सो यहां पे आ जाता है हाफ, ये आ जाता है g by 2. g by 2 होता है 5. अगर मैं 10 मीटर्स पर सेकेंड स्क्वायर करूं तो 10 by 2 इज 5. देन ओवर हियर माइनस a वी गॉट एज हाफ, a वाज हाफ डिवाइडेड बाय नीचे का होता है 5√3. तो फिर यहां पे लगाते हैं दिस अप टॉप, इट विल गिव यू 10 minus 1 दैट इज 9 by 2. 9 by 2 नीचे हो जाएगा तब 10√3. ठीक है. 9 by 2 डिवाइडेड बाई 10√3. यू कैन अंडरस्टैंड, अगर इसको करो 1.7 लिखो, ऊपर 90 लिखो, देन यू विल सी दैट 17 90 के साथ वहां पे जाए, बिकॉज एट 85 17 into 5 is 85. Okay, since it's a bit more than 17, it's 1.732, so I can understand this would go with 0.5. ठीक है. Approximation, ये calculations का जुगाड़ is the key to solving physics questions quickly in the exam. And I cannot tell you the emphasis of solving physics questions quickly, क्योंकि maths तुम्हारा वैसे ही ज़्यादा time लेगा. So the one who solves physics questions quicker is the one who gets more time in maths and can get more questions over there. 30-50 seconds before you solve, so that you can attempt the problem properly. Okay, Jaydeep, as I'm doing, you try on your own. You keep trying on your own. Generally, it will take me a bit longer to get there. But anyway, when you finish, just let me know. Okay? So this is, now see, Jaydeep, if you have not solved it so far, then I'll show you how you could solve this question in like literally, I would say 5 to 10 seconds. This took me around 1 minute, 2 minutes, पता नहीं कितना time लगा, 2 minutes. This can be solved in 10 seconds. How do you solve it in 10 seconds? This calculation will take you 10 seconds. Stops. If you know mu s is tan 30 is 1 by √3, just a slight approximation, you get 0.6. Mu s is 0.6. There are two options. Immediately look at the options. Two options are this mu s 0.6 and it can be this mu s 0.6. What do we know for a fact? We know for a fact that the kinetic friction has to be less than the static friction. Only one option satisfies that. That is option 1. You did not even have to do this. Yahi se you could directly jump to the answer over here. Okay? Yes, mu k is always less than mu s. Just by that logic you can do it over here. And even if you say what if mu k is greater than mu s? That is not possible. Because if mu k was greater than mu s, it would not slide down. If mu k was greater, even at that angle, from static friction it went to kinetic friction. As soon as it starts moving, it would stop because kinetic friction is too strong. Okay, so just by that you can mark it over here. Let's look at the next question. This says a block of mass m is resting on a smooth horizontal surface. One end of a uniform rope of mass m by 3 is fixed to the block, which is pulled in the horizontal direction by applying a force F at the other end. The tension in the middle of the rope is. तो यहाँ पे let's draw it out. Originally you have the mass here, mass m, and you have the full string, and it's a thick string because it has a mass, but you want at the midpoint, you want the tension at the midpoint. So what we will assume is that the string is actually made up of two pieces. Half of the string length is over here and the other half is over here, and in between we assume that there is a light or like massless string, and over there I need to find the tension. Okay? So this is m by 3 and each piece is going to be m by 6. each piece is m by 6 because the total length mass of the string would have been m by 3. Okay, Rajesh Goth, one shot of full mechanics theory part. Okay, you deleted the message. So if you want, just you can let me know over there. I'll try to put one session, organize a session. So यहाँ पे firstly I'm applying a force F. Forget about this middle part. If you look at the full system as a whole, then the acceleration A is equal to force divided by the total mass. What is the total mass? It is m plus m by 3. M plus m by 3 is 4m by 3. So this becomes 3f by 4m. This is the acceleration of the entire thing. Now I can look at just this body. In this body, the only force acting is the tension force. And that tension is capable of moving this body at this acceleration because acceleration remains the same throughout. Okay, so let's do that. T is equal to, now this mass, just this mass, which is m plus m by 6, that's going to be 7m by 6 into the acceleration A, which we got as 3f by 4m. Let's cancel out the masses over here. We have, what else can go? Here I can go with 2. So I have 7 divided by 2 into 4, 8. So 7f divided by 8. 7f by 8. Fine? Yes, that's right, Jaydeep. It's 7f by 8. Okay, one shot, full mechanics. Fine. Rajesh, I'll try to organize one session before your JEE itself. One shot of full mechanics part. Mechanics 1 can be covered in one session. Mechanics 2, I'll have to create a separate session. Anyway, let's move on. Next one, यहाँ पे है कि a particle describes a horizontal circle in a conical funnel whose inner surface is smooth with a speed of 0.5 meters per second. What is the height of the plane from the vertex of the funnel? ये बहुत अच्छा है. This is a good question, interesting question because here you have to use a lot of logic. So let's visualize this first. यहाँ पे I have the cone and I'm seeing it from a 2D point of view. ठीक है? Because 2D पे I can look at things easier. Let's assume that this angle here is theta. The semi-vertical angle is theta and the particle is somewhere around here. The normal reaction from this conical wall is given by n. Now understand what are the forces that bring about this normal reaction. First, there's obviously the force of gravity. That's straight down, that is mg. And in this direction, you have the centrifugal force, which is mv square by r. This is the force in this direction because if you have the cone like this, the particle is moving like this in the cone. So if you look at the side, then the force should be exactly horizontally on the side, not along the surface. It's horizontal. Surface is at an angle, but it's horizontal to that surface. So over here, if I take the angles, consider the angles, then what do I get? If this angle is theta, then this angle would be 90 minus theta, which means this angle again is equal to theta. So n cos theta is equal to mv square by r. And let's side में रखते हैं, n sin theta is equal to mg, right? Also, this r can be represented in terms of the height. We want the height from the plane over here. So I need this height over here. So if I complete the right angle triangle, you can see that this r is this part. That part is r, right? Over here, r by h is equal to tan theta. So r is equal to h tan theta. We can put that over here. We have n cos theta is equal to mv square by h tan theta, right? And this n is equal to mg by sin theta. We can take it from here. So I'll keep it as mg by tan theta. Why do I do tan theta? Because I have a sin theta at the bottom because of mg by sin theta and cos theta up top. So that is 1 by tan theta is equal to mv square by h tan theta. Cancel out your tan thetas, doesn't matter, which is good because this theta I had approximated. If the theta remained, I would have been in trouble. So over here, cancel out the m's also. You have h is equal to v square by g. So what are the values? You have 0.5 meters per second, 0.5 square, that is 0.25 divided by 10, that is 0.025. Okay, that is 0.25 centimeter. Fine, this is 0.025 meters, so that is that is 2.5 centimeter. My bad. This is 2.5 centimeter. Okay, everyone clear with this? Okay, chalo let's move on to the next question. This is a good conceptual question because यहाँ पे a lot of students would make the mistake कि this centrifugal force would be perpendicular to the plane of the cone, but that is not it. Always remember, centrifugal force is in the same plane as the circle is in. Okay? Next question पे जाते हैं. It says कि a particle tied to a string describes a vertical circular motion. Radius r continually. It has a velocity of √3g by r at the highest point. Ratio of the respective tensions in the string holding it at the highest and the lowest point is. तो पहले निकालते हैं कि velocity at the highest point तो दिया हुआ है √3gr. We also need to find out what is the velocity at the lowest point. तो उसके लिए क्या करेंगे? Suppose if it is, this is the vertical circle, here the velocity is √3g by r, here let the velocity be v. तो यहाँ पे what is the total energy? Total energy is the kinetic energy because of this velocity, plus it is now at a height of 2r. There is a height of 2r over there. So the total energy over there, वहाँ पे total energy होगा half mv square. This is 3gr. V was √3gr, so this would be 3gr plus यहाँ पे the mgh, but h is 2r, okay, because the radius is r, so h is 2r, so 2mgh, 2mgr. वहाँ पे capital R and small r are the same thing. Let's make it small r only over here so that there is no confusion. So this gives me what is the total energy at the top point. Conservation of energy लगाते हैं, which means I equate this with the total energy at the bottom point. Bottom point में ये potential energy का factor रहेगा नहीं. You only have the kinetic energy over there, so that will make it half into mv square. ठीक है, v तो पता नहीं अभी तक. So remove these halves and make this 4. ठीक है. Then you have over here 5 mgr. नहीं 5 नहीं, sorry, 7 mgr. 3 है, there's 3 over here. तो 7 mgr is equal to, remove the m also, is equal to v square. Fine. Now I need what is the tension at the 2 points. Firstly, I got the velocity at the bottom point. At the bottom point, remember that mg also acts in the same direction as the centrifugal force. So the total tension T bottom, it is mg plus mv square by r. So mg plus what is over here, this would be 7gr divided by r. That is why I kept v square as it, root मत निकालना यहाँ पे. So there is also an m because over there is an m. So that is 8 mg. Okay, this is 8 mg over here. And in the second case, at the top point, T top, this is equal to mg, or rather mv square, because it's a complete circle. So mv square by r minus mg. क्योंकि यहाँ पे mv square by r is in this direction, centripetal force, centrifugal force, and the gravity is downwards. They are opposing each other. तो यहाँ पे अगर करते हैं, remember at the top point velocity was 3gr, so that makes it 3mg minus mg, that is equal to 2 mg. So bottom it's 8 mg, top it's 2 mg. Like I'm telling, I'm taking a long step here. This should be done a lot faster because this is there in your NCERT only. ठीक है, the vertical circle thing. So you should be doing, I'm breaking it down for you so that everyone understands, but generally it's 1:4. You have to do it a lot faster, 8 mg and 2 mg. Okay, these things, these calculations over time, you should try कि these calculations need not be solved rigorously. ठीक है, ये intuition में आ जाना चाहिए कि अरे वहाँ पे plus extra 2 का factor आ जाता था. Like from here you'll see like 3 say it's going to, when you shift here it will go to 3 mgr to 5 mgr. From here it will be 7 mgr. That is how you should remember it. With practice it will come. Next up, block of mass m placed on a surface with a vertical cross section given by y is equal to x cubed by 6. If the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping is. It's a very interesting question क्योंकि जहाँ पे हम लोग block या slippage का बात करते हैं, there we don't really see an equation between y and 6. ये trajectory का part नहीं दिखता है. So let's draw it out. Firstly, y equal to x cubed by 6 graph will look like somewhat like this. ठीक है, I am looking at any point over here. तो उस point पे if I place a mass, then again it will have two competing forces. It will have there's a friction given by, कहाँ है friction is जो भी it's mu. You will be having mu mg cos theta on that direction, and you would be having mu mg sin theta in the downward direction. And I can assume कि ये तुम समझ लो कि एक inclined plane ही है, okay, with an angle theta, right? So you want that at the maximum point, you want कि these two forces become equal, means the limiting value of friction is reached. So if you do that, you will get mg sin theta. Again, I'm elaborating steps. These should be done mentally. mg cos theta, mg hatao. You have mu is equal to tan theta. ये should be there mentally. Angle of repose. When does it start? When does it start turning? Where does it start slipping? Now tan theta we don't know, but tan theta is a slope of a line. Slope of a line का दूसरा relation क्या है? It's a derivative. Tan theta is equal to dy dx. So mu is equal to dy dx, because dy dx and tan theta are both equations of a slope. So यहाँ पे y दिया हुआ है, I can differentiate it with respect to x. I will be getting 3x square by 6. इसको हटाओ यहाँ पे. This gives me a factor of 2 here. So x value I need to find out. Mu is given as 0.5. So if mu is 0.5, which I'll write as half, that is equal to x square by 2. Cancel this out. You get x is equal to 1. That is not the answer that you have asked. They have asked what is the height. Height means you want the y value. So put this x is equal to 1 in this equation here. You'll get y is equal to 1 by 6. That is the correct one. Yeah, 1 by 6n. That's right, Jaideep. Okay. Next up, I see a lot of viewers, but I want you to try to solve these with me. Then you'll get the most value. You'll see if you get stuck with anything. You can ask me and I can clear doubts precisely for you about where you might be making a mistake, where the concept could be wrong for you. So next question, stationary body of mass 3 kg explodes into 3 equal pieces. 2 of the pieces fly off into mutually perpendicular directions, one with a velocity 3 I cap meters per second, other with a velocity 4 j cap. If the explosion occurs in 10 to the power minus 4 seconds, what is the average force acting on the third block? So part collisions, part force over here. So first body goes up in 3 I cap. So 3 I cap I can assume is in this direction. Second body goes with 4 j cap. So over here this is 3, this is 4, and the momentum, remember the mass is same because it breaks up into equal pieces, 1 kg each. So over here you have 4 kg meters per second and here you have 3 kg meters per second. Now since this particle exploded from rest, you know that the momentum of these two should be opposed by should be like technically be balanced by the momentum of this side. A momentum of this particle over here, this again has the same mass of 1 kg. So since this vector needs to cancel out these two vectors, you can see that the answer would be minus 3 I cap plus 4 j cap. Because minus 3 I cap minus 4 j cap, because minus 3 I cap cancels out this, minus 4 j cap cancels out this. But that is the momentum. You want the force force is just the momentum divided by the time. So the momentum divided by 10 to the power minus 4, 10 to the power 4 comes in the numerator. Okay, I'm not going into the calculation here, it's self-explanatory just based on that diagram. Okay. If any of you are seeing this in the PDF in our Telegram group, and then if you don't get it, just come back to the video and see it, it's explanatory. Next, a body is moved along a straight line by a machine delivering constant power. The distance moved by the body in time t is proportional to. So, यहाँ पे what do we know as the relation for the power? Power का relation होता है, it's given by Fv is equal to half mv square. ठीक है, या फिर यहाँ पे हम लोग बाय मशीन डिलीवरिंग, चलिए यहाँ पे एनर्जी के बेसिस पे करते हैं. वी नो दैट द velocity over or the work done in time t, the work done in time t is equal to p into t. ठीक है, it is p into t. So this work done brings about the kinetic energy. We can go by that way. So half mv square is equal to P into T. This is work energy theorem. ठीक है? If you do that over there, you will get V is equal to some constant into T. I don't care about this too. Don't use up your mind space with this. I don't care. Answer only wants it what is proportional to it. Keep it as a constant T to the power half. Next, since I want the distance moved, I know V is equal to dx dt. So rather dx dt equal to c t to the power half. I'll elaborate the steps. So x is just integration of c into t to the power half dt. So you will get just from here x as proportional to t to the power 3 by 2, because n into x to the power n plus 1, again don't care about what constants are, anything, only I need the proportionality. So don't waste your time writing, some people put constants of integration here, you don't need to bother about that. Next question, particle of mass m is driven by a machine that delivers a constant power of k watts. If the particle starts from rest, the force on the particle at time t is, so again we can use the same relation, we can proceed by the same way over here. We know that power is equal to, or this work is equal to, we can go by work way or we can even go by the other way, force on the part. अच्छा, we need the force over here. ठीक है, चलो let's do it with F. ठीक है, F into V is equal to a constant which is K over here. Force can be written as M into A, and A is equal to dV dt into V, and that is equal to K. So over here I get V dV is equal to K by M dt. V dV is equal to K by M dt. You will get V square by 2 is equal to KT by M. So V is equal to 2 KT by M into root. Fine. Next thing, we need the force, right? We have got the velocity down. Just a moment. Force on the particle at time t. Chalo, this way I'm assuming kahin pe I'm making a mistake. Let's go the energy route again. Okay, I just want you people to try the energy route. Solved by using P equal to, answer is D, Jaideep. Answer is D maybe, but I'm trying to go by the energy route over here, which is the shorter way. You people try the energy route. Tell me, if I go by the energy route again, I can use, we got V, right? We want the force. So if I just differentiate this, do I get any benefit over here? I can differentiate this and actually get a benefit. This is quicker, because if I do A is equal to dV dt, A is equal to dV dt, then I get this part, root over 2k by m comes out, and you have differentiating t to the power half, that gives you 1 by 2 root t. This is quicker. So यहाँ पे 1 by 2 root t, this is acceleration coming out. This would be नीचे में लगाओ 4 over here, this comes up with k by 2m into root t to the power minus half. ठीक है? Did I do all the numbers correctly? It comes in as a 4, 2 goes with 4, yes. So now I need the force. Force is mass into acceleration. If we put that in, this m part goes in as an m square, keeping an m up top, you would get root over of mk by 2 into t to the power minus half. This method was quicker. I was contemplating if we go by the energy method or not. Fine? That's right, Jaideep. It is option D over here. You can put the value of V in P is equal to FV over here directly. Do we get the same answer that way? If I put V over here, K by V, right? So M goes up top. You have a K that comes in. You have 2 at the bottom. Yeah, even that will do. Even that will do. That is because over here we have the constant power. If the power was variable, you will have to go through this way. Okay, that's a good observation, Jaideep. You can directly put it over here and you would get the answer. Good work. Next question. Moving body with a mass m1, velocity u strikes a stationary body of mass m2. The masses m1 and m2 should be in the ratio of m1 by m2 so as to decrease the velocity of the first body to 2u by 3 and giving a velocity of v to m2. Assuming a perfectly elastic impact is, then the ratio m1 by m2 is. Now first thing is very clear. We'll use the conservation of momentum. Conservation of momentum से क्या मिलता है? We get m1 into motion कहाँ पे है? It's used velocity u. m1 u. Second body is at rest, तो उसके बारे में सोचना नहीं है. This is the entire initial momentum. Final momentum में you have m1 moving with a velocity 2u by 3 and m2 moving with a velocity v. And यहाँ पे the crucial thing is, you might seem like this is very basic, but यहाँ पे crucial thing is कि ये 2u by 3 मैंने positive क्यों रखा? How can I be so sure कि the first body comes, hits the second, how do I know it doesn't bounce back? उसके लिए look at the question, it says that it decreases the velocity. This tells you कि it's moving in the same direction. So question में occasionally ये hints छुपे होंगे. You'll have to read and understand based on that. तो m1 2u by 3 हटाओ तो m2v is equal to m1u by 3, right? यहाँ हो गया मेरे को v और u का एक रिलेशन मिल गया. I need one more relation with which I can work with. So I shift to this perfectly elastic impact और यहाँ से coefficient of restitution. Coefficient of restitution का relation क्या था? E is equal to v2 minus v1 divided by u1 minus u2. This was the velocity of reapproach by velocity of approach. So while going away, what is the velocity of reapproach? It is v minus 2u by 3, and while approaching, because first this is just the relative velocity, ठीक है? While approaching, it was just u. It was just equal to u because one body was at rest, so the relative body distance between them is equal to u. Jaideep, decrease given, yes, that's right, decrease is given. That is why we were able to figure it out. So perfectly elastic collision में E value, coefficient of restitution, is equal to 1, which means my equation becomes u is equal to v minus 2u by 3. So v is equal to 5u by 3. यहाँ से मिला मेरे को 5u by 3. I can put that in here. I have m2 into 5u by 3 is equal to m1 into u by 3. 3 हटाओ, u's को हटाओ यहाँ पे, you get m1 by m2 is equal to 5. Okay, that is the correct answer. Yes, Jaideep, you think it is 5:1? In solving JEE questions, you don't think, you have to get to it. Thinking is like the initial stage where you're just testing to see if an option is correct or not. Because this you would get a precise value over here. Okay. Next, two similar springs P and Q have spring constants Kp and Kq such that Kp greater than Kq. They are stretched first by same amount, then by the same force. The work done by the springs Wp and Wq are related in each case over here. So first case is they are stretched by the same amount. So what is the relation? W is equal to half kx square. If they are stretched by the same amount, meaning this x is constant, which means this is case A. This is case A. In that case, W is proportional to just k because x is same for both of them. So over here, since Kp is greater than Kq, we know in first case Wp would be greater than Wq. So right off the bat I can know this is the correct answer because there's only one possibility here. But I also want to show you the other case where they are stretched by the same force. If they are stretched by the same force, then remember K is also not same, K is different, X will also not be the same because it's same force, because of different K the stretching would be different. So you need to bring it down to a single variable changing. How do you do that? Since you know that the force is equal to Kx, I can write that X is equal to F by K. If I replace X over there, then in case B, I have W is equal to half K into, in place of X I put F by K, makes it F square by K square. Remove this, now I have only one variable on which it depends, and that is K, because force is constant in case 2. So you see now work done is inversely proportional to K, which means if P is greater than Q, work done of P will be less than Q. So you can see that over here, work done by Q is greater than work done by P. Okay. Next up, glass marble dropped from a certain height above the horizontal surface, reaches the surface in time t, then continues to bounce up and down. Time in which marble finally comes to rest is. तो यहाँ पे we'll be using a formula for bounce height, जो कि बहुत students नहीं जानते हैं या फिर ये derive कर सकते हैं, but this is a quick, small, easy formula to remember, and that will make this question very easy for you. Okay? तो यहाँ पे लिखते हैं time in which marble finally comes to rest, right? So originally when you drop it, the time t net is equal to, the first drop time is root over of 2h by g. First drop time हो गया root over 2h by g. We know that is the formula for time released of free fall. Plus now it bounces up. When it bounces up, how high will it bounce? It will bounce by a height of e square h. Remember that the bounce height for bouncing back, if the coefficient of restitution is e, then the height it will bounce back h dash. This is the formula I'm talking about, that many students either don't know or they don't remember this formula. This can be derived by the way, but it's a long derivation. You don't want to go there. Okay? So h dash is e square by h, which means in the next case the time it will take for the next bounce to complete is 2 into root over of 2 e square h divided by g. ये तो h की जगह h dash लग गया, e square h. But why do I have this factor of 2? Because in the first case it was just the fall, but this is the time it takes to bounce, come up, then go down. So it's twice of this time, twice of that formula. That is why you have the factor of 2 here. Plus अगले bounce के time the height will become e squared times of this, so it would be e to the power 4h. So you'll again have 2 root over of 2 e to the power 4h divided by g. Similarly you would, next one you would have 2 root over of 2 into e to the power 6h by g, and so on. हर स्टेप पे ये चलता रहेगा. This is the total time of first drop, first bounce, second bounce, third bounce, and so on. So let's see how we can simplify this. T net is equal to, this is the normal time, the time it takes to reach the surface t. So t plus 2et. Why? Because e square comes out as e. Once you take it out, you just have 2h by g, which is t we just got. So 2 e coming out e into the remaining part t. So 2et, next one would be 2 e squared t, next 2 e to the power 3t, and so on. You see the geometric progression here. T plus, you take the 2et out and you would be having 1 plus e square plus so on up till infinity. Now I can find the sum to infinity because e value is a fraction, it's less than 1. Good work Jaideep, you're getting it before I finish, that is good. T plus 2et into 1 by 1 minus e, because for a infinite geometric progression the sum of terms. So over here you can just take t common. this T if you take common, then 1 minus E over here will give you 1 minus E plus 2E divided by 1 minus E. So you'll see you'll get T into 1 plus E by 1 minus E. Fine? Everyone clear with this question? Let's move on. This formula, remember, okay, this formula can help you a lot in JEE. If you try to, without this, firstly, if you have never heard of it, you'll not be able to even work this sum. Okay, you'll not be able to work this sum. So this formula will help you solve it. It's not like it will save you time. It will help you to solve this. Otherwise you can't. You won't even think of deriving it over there. Next up, in the figure shown, particle of mass m is released from the position A on a smooth track. When the particle reaches point B, then the normal reaction on it by the track is. So you see this full path turning. Don't have to bother about it. It's because it's a smooth track, the path matter नहीं करता है. क्या मैटर करता है? सिर्फ कि इसका हाइट कितना चेंज हो रहा है. 3h हाइट से it's coming to a height of 2h, right? Because this is radius is h, तो इसका height हो जाएगा अभी 2h. So total drop in height क्या हुआ? It's just h from 3h to 2h. So over here the velocity I can then write half mv square is equal to mg into h. V refers to the velocity over here. यहाँ पे I'm releasing it from rest. So the kinetic energy that is here is because of the change in potential energy between these two heights. Okay. So we have half mv square is equal to mgh. So v square is equal to 2gh. What do we need next? We need the normal reaction on it by the track. So यहाँ पे normal reaction किस factor के लिए होगा? एक है because of this v square. एक तो सेंट्रीफ्यूगल फोर्स उस साइड जाएगा, दूसरा mg नीचे एक्ट करेगा. सो द नेट नॉर्मल रिएक्शन n वुड बी इक्वल टू द सेंट्रीफ्यूगल फोर्स माइनस mg. सो दिस विल गिव यू mv स्क्वायर बाई r इज इक्वल टू h. सो आई कैन जस्ट डू दैट. mv स्क्वायर तो देगा तुम्हें 2gh डिवाइडेड बाई r विच इज द रेडियस इज जस्ट h माइनस mg. h हटाओ, you have 2mg minus mg is equal to just mg. So our correct answer is mg. Okay, we get that? Good work, Jaydeep. The answer is mg. I want the rest of you also to keep answering. Jaydeep is the only one who's answering at the moment. Keep answering, keep yourself on track with us. Okay, so that is when you'll get doubts. Otherwise तो ये session तुम लोग recorded भी देख सकते हो. Live का फायदा ये होता है कि you can ask me directly and I'll answer right away. Okay. Next, a block of mass m rests on a rough horizontal surface. Coefficient of friction is mu. When a bullet of mass m by 2 strikes horizontally and gets embedded in it, the block moves a distance d before coming to rest. The initial velocity of the ballet नहीं होगा, bullet होगा. Bullet is k root over of 2 mu gd. Then the value of k is. तो यहाँ पे firstly block of mass m है. तुम अगले बुलेट से आके m by 2 से हिट कर रहे हो. सो यू फर्स्ट नीड टू फाइंड आउट व्हाट इज द, लेट्स अज्यूम द इनिशियल वेलोसिटी ऑफ द बुलेट इज u. तो व्हाट वुड बी द वेलोसिटी ऑफ द एंटायर सिस्टम एज इट मूव्स? काइनेटिक ये कोलिजन्स का रिलेशन यूज कर सकते हैं विद इनइलास्टिक कोलिजन. सो द इनिशियल वेलोसिटी इज m by 2 u बिकॉज बुलेट का मास था m by 2. m by 2 u is equal to m plus m by 2 into v, because after the bullet enters, the bullet sticks with it, so the total mass becomes m plus m by 2, block mass plus bullet mass. So that makes v will be equal to, ये तो चलो 3 by 2 हो जाएगा, cancel the 2's, the 3 comes down, v is equal to u by 3. Next thing, what do we need? The block moves a distance d before coming to rest. अभी ये जब गया, now there's the frictional force that is acting in this direction, and the frictional force F, let's do it here. F is equal to mu mg, but mu into 3m by 2 into g, क्योंकि मास जो है अभी इसका वो m plus m by 2 है. So F, the frictional force, is mu into 3m by 2 into g. Next, I want the distance moved, right? Now whatever energy that this brought in, whatever energy this mass brought in, that is the energy that is going to convert into the, it's going to be dissipated by this frictional force. ठीक है, मेरे को लगता है मैं वो खाली खाली में किया. But anyway, over here I need to find what is the energy that this one brings. The energy that this brings is half into 3 by 2 है, right? It's 3 by 2. Okay, just a minute. We'll not go by that relation. We will not go by that relation. We'll go by the acceleration relation only, and I'll tell you why. We'll go by the acceleration relation only. यहाँ पे we got this as the frictional force, which means the acceleration that comes is equal to mu into g. Fine, acceleration is mu g. You have the initial velocity given to you. You want the distance after which this velocity goes to 0 because of this acceleration. So we'll use the relation of v square minus u square, or rather u square minus v square divided by 2a is equal to s. S is this d over here. So u square, v to 0 hai chalo because it will stop over there. So u square is u square by 9. Right, v square, that is what is remaining. Be very careful, this is actually this v. ठीक है, u is v. I'm using different, यहाँ पे गड़बड़ हो जा रहा है मेरा in terms of variables. Let's keep it v square minus 0 होगा. चलो इसको ऐसे ही लिखते हैं so that there is no confusion. v square minus 0 square because it starts at v, ends at 0. So v square minus u square, तो ये v square के जगह you get u square by 9 because v is u by 3, and नीचे you have 2 into mu g, and that is equal to d. What you want this u, so u is equal to, when you cross multiply you get root over of 9 into 2 mu g d. ठीक है, and then you'll have this coming out as 3 root over of 2 mu g d. So your correct answer would be answer B. Okay. One thing यहाँ पे I'm telling is why I did not go by the energy route, because energy, I was first thinking of equating the energy that the bullet comes in with the energy that is dissipated. But वहाँ पे we'll be making a mistake, because the energy the bullet comes in is not the energy that is dissipated in this part. A part of that bullet's energy is also dissipated when it enters in here, because it's an inelastic collision. तो इसके एनर्जी के साथ इसका डिसिपेशन इक्वेट करेंगे तो गलत आएगा. ठीक है, if you were thinking that way, that would have been incorrect. तो इसका एनर्जी, a part of it is used up during that inelastic collision, or whatever remains, that is going to the other side. That is why वो वाला एनर्जी इक्वेट नहीं किया, हम लोग नॉर्मल न्यूटन्स इक्वेशन से ही आगे बढ़े. Fine. Let's move on. Hollow sphere is held suspended. Sand is now poured into it in stages. Center of mass of the sphere with the sand rises continuously, remains unchanged. So here the option is first falls, then rises. इसका लॉजिक क्या है? Originally, if the sphere is there, यहाँ पे sphere है, and it is empty. If it is empty, then its center of mass is over here, because it's a uniform sphere. Center of mass center में. लेकिन जैसे you add sand, जैसे ही तुम sand दोगे ना, इसका जो center of mass है वो drop करेगा, because mass is now concentrated at the bottom. और फिर जैसे जैसे तुम sand डालते जाओगे, sand का level उठता जाएगा, ये center of mass भी उठता जाएगा, so that when the sand is full, then again center of mass comes back to the center of this sphere over here. ठीक है, तो पहले जैसे ही डालोगे center of mass drop करेगा, फिर जैसे जैसे sand भर रहा है उसके साथ center of mass ऊपर आएगा. Same thing can be done in reverse as well, as in they will tell you कि there is a sphere and sand is coming out. What happens to center of mass? तो जैसे sand is coming out, center of mass drops. As soon as the sand just depletes, it will bounce back. It not bounce, मतलब वो discontinuous function नहीं होता है. It will come and then it will, towards the end, it will again go back to the center. Okay. Next up, from a solid sphere of mass m, radius r, a cube of maximum possible volume is cut. Moment of inertia of cube about an axis passing through its center perpendicular to one of its faces is. Interesting question है, because यहाँ पे you need to take care of multiple things. जैसे सबसे पहले understand करना है कि अगर तुम एक स्फीयर में से क्यूब काट रहे हो, what is the maximum size of the cube that you can cut out. So in 2D में अगर ड्रॉ करते हैं तो 2D में ये सपोज तुम्हारा स्फीयर है, तुम्हें इसमें से अगर क्यूब काटना है, अगर मैं 2D में ही देखूं तो दिस वुड बी द स्क्वायर, दिस वुड हैव टू बी द स्क्वायर, जहां पे स्क्वायर्स के जो कॉर्नर्स होंगे वो तुम्हारे स्फीयर के सरफेस को टच करेंगे, स्फीयर के एकदम एज को टच पे रहेंगे. एंड इन दैट केस यू कैन अंडरस्टैंड दैट जो डायगोनल होगा दैट वुड जस्ट बी द डायमीटर ऑफ द स्फीयर ओवर हियर. तो अभी एक स्फीयर का क्यूब का डायमीटर क्या होता है, क्यूब का डायगोनल क्या होता है, क्यूब का डायगोनल इज गिवन बाय a√3, that is the diagonal of a cube, that has to be equal to the diameter of the sphere which is equal to 2r. तो मेरा जो a होगा, a would be equal to 2r divided by √3. तो मेरे को मिल गया कि लेंथ क्या होगा, what would be the side of the cube. Next thing I need is what is the mass of the cube. Mass of the cube के लिए क्या चाहिए मेरे को, mass of the cube is m dash, total mass of the sphere is m divided by 4/3 pi r cube. ये हो गया तुम्हारा mass per unit volume multiplied with the volume of the cube which is a cube. तो यहां पे अगर करते हैं a का वैल्यू ऊपर से लगाते हैं तो m by 4/3 और अदर 3m 4 pi r cube into a cube. जैसे ही करते हैं ऊपर आई वुड बी गेटिंग 8 r cube डिवाइडेड बाय नीचे आएगा 3√3. ठीक है, सो व्हाट ऑल कैंसिल आउट, दीज 3s कैंसिल आउट, आई कैन टेक आउट 2 हियर और कुछ कटता है, r cube कटता है, सो आई गेट m dash is equal to 2m by √3 pi. ठीक है, 2m by √3 pi. Just if you are doing it with me, moment of inertia formula of a cube is ma square by 6. ठीक है, ma square by 6 will give you the moment of inertia of a cube. चलो, it is 2m by √3 pi, that is m dash. अब m dash के बाद अब हम लोग निकाल सकते हैं कि moment of inertia about its center perpendicular to it क्या होगा. So the moment of inertia of the square is m dash a square divided by 6, क्योंकि that is the formula of the moment of inertia of a cube. तो यहाँ पे because remember moment of inertia of a normal edge वाला होता है ml square by 12, तो उसका हाफ हो जाएगा जनरली, ma square by 6 होगा. So m dash is 2m by √3 pi into a square by 6, यहाँ पे एक और फैक्टर ऑफ 6 है, into a square is so 4r square divided by, this is squared, so this will come with a factor of 3. So we have, let's cancel some out, let's 3 निकला यहाँ से, so I have 4mr square divided by 3 into 3, 9√3 pi. So our correct option is option A. Yes, Jaideep, that is option A. Okay, next question. This was a tricky one because ये वाला तो चलो कुछ लोग फिर भी निकाल लेंगे, लेकिन लोग मिस कर जाते हैं कि मास को भी चेंज करना है, मैक्सिमम वो मास ऑफ क्यूब क्या निकलेगा. Next, a ball rolls without slipping. Radius of gyration of the ball about an axis passing through its center is k. If radius of the ball be r, then the fraction of the total energy associated with its rotational energy would be. तो यहाँ पे यार this you should know कि ये k square by k square plus r square होगा. That is because ये जो k square by r square, ये जो r square वाला पार्ट है, that comes from your translational motion, और तुम्हारा जो रोटेशनल है वो k स्क्वायर के साथ जाएगा, बिकॉज योर टोटल काइनेटिक एनर्जी इज इक्वल टू हाफ mv स्क्वायर प्लस हाफ i ओमेगा स्क्वायर है. i को हम लोग लिखते हैं एज mk स्क्वायर, वेयर k इज द रेडियस ऑफ जायरेशन, इनटू ओमेगा स्क्वायर है वो फिर हो जाता है v स्क्वायर बाय r स्क्वायर. ठीक है, सो वहां से तुम्हारा आ जाएगा एज दिस इज हाफ mv स्क्वायर इंटू 1 प्लस k स्क्वायर बाई r स्क्वायर. उस बेसिस पे अगर करते हो, यू विल गेट दिस एज द पार्ट, दिस इज द फ्रैक्शन ऑफ रोटेशनल एनर्जी ओवर देयर. दिस इज बेसिक फॉर्मूला बेस्ड. Next, two masses m1 and m2 are connected by a massless spring of spring constant k, unstretched length L. Masses are placed on a frictionless straight channel, which consider our x-axis, which we consider hoga. They are initially at x equal to 0, x equal to L respectively. At t equal to 0, velocity v0 is suddenly imparted to first particle. Later time, center of mass of the two masses is. So, velocity लेने से पहले, where does the center of mass lie? The center of mass would lie at xc is equal to m1 into 0 होगा तो उसका तो तुम भूल ही जाओ. m2 is at L, m2L divided by m1 plus m2. एक्चुअल फॉर्मूला है m1 into 0 plus m2 into L. m1 into 0 तो 0 हुआ, तो इसीलिए m2L by m1 plus m2. ये हो गया xc, सेंटर ऑफ मास का ओरिजिनली द सेंटर ऑफ मास. अभी जैसे ही आई गिव दिस वन अ वेलोसिटी ऑफ v नॉट दिया हुआ है, क्या वेलोसिटी जैसे ही मैं इसको देता हूं वेलोसिटी v नॉट इसको, तब इवन द सेंटर ऑफ मास गेट्स अ स्पेसिफिक वेलोसिटी. और वेलोसिटी रिलेशन फॉर अ सेंटर ऑफ मास इज जस्ट vc इज इक्वल टू m1 v1 प्लस m2 v2. सिमिलर है, एकदम डिस्टेंस के जैसा है, m1 प्लस m2. सो v2 इज टू 0 क्योंकि इस वाले को मैंने कुछ दिया नहीं है, तो वेलोसिटी ऑफ द सेंटर ऑफ मास बिकम्स m1 v0 डिवाइडेड बाय m1 प्लस m2. राइट, तो दिस इज द वेलोसिटी ऑफ द सेंटर ऑफ मास. तुम अब भूल जाओ कि ये दो पीस है. दिस इज जस्ट अ केस जहां पे तुम्हारा वो पॉइंट पार्टिकल है विच इज ओरिजिनली एट दिस पॉइंट गिवन बाय दिस x, एंड देन दैट पॉइंट पार्टिकल्स मूव्स विथ दिस वेलोसिटी ओवर हियर. तो व्हाट इज द न्यू पोजिशन? न्यू पोजिशन होगा तुम्हारा, दिस वुड बी योर करेक्ट आंसर, क्योंकि ये तुम्हारा ओरिजिनल पोजिशन था प्लस वेलोसिटी इनटू टाइम. ओके, जस्ट बोथ ऑफ देम एंड यू विल गेट इट. Jaideep, m1 v0 m1 plus m2, are you telling the answer or you're just giving this relation? Because the answer is, as you can tell, the answer is over here, m2l divided by m1 plus m2. Original position plus distance moved in time t with a velocity given by that. चलो next question पे जाते हैं. Moment of inertia of a body about a given axis is 1.2 kg meter square. Initially body is at rest. In order to produce a rotational kinetic energy of 1500 joule, an angular acceleration of 25 radians per second square must be applied about that axis for a duration of. तो यहाँ पे मेरा energy है, we have been given that moment of inertia. So kinetic energy का relation क्या है? It's 1500 is equal to half I omega square. So 1500, so पहले नंबर लिख दिया, 1500 is equal to हाफ इंटू, और इसको हटाओ, यहाँ पे क्रॉस मल्टीप्लाई करते हैं, 2 डिवाइडेड बाई आई का वैल्यू है 1.2, बट इंस्टेड ऑफ राइटिंग 1.2 जो कि कैलकुलेशन मुश्किल करेगा, वी राइट इट एज 6/5. ठीक है, आई एम जस्ट जंपिंग स्टेप्स ओवर हियर. इफ यू हैव डाउट जस्ट आस्क मी. 5 into 2 ये हो गया तुम्हारा ओमेगा स्क्वायर, तो 6 तो 1500 से जाएगा एट 250. 250 into 10 makes it omega is equal to root over of 2500, that is equal to 50 radians per second. अब इसके आगे तो तुम्हें देखना भी नहीं है, ओमेगा अगर 50 radians per second है और acceleration 25 radians per second square है, so the time will just be 2 seconds. Okay, fine, let's move on to our next question. अगर तुम लोग को ये क्वेश्चन वैल्यूएबल मिल रहा है तो लाइक कर देना वीडियो को. इट रियली हेल्प्स अस आउट टू कीप ब्रिंगिंग दीज क्वेश्चंस ओवर हियर फॉर यू. तो एनीवे, नेक्स्ट क्वेश्चन. अ पुली ऑफ रेडियस 2 मीटर रोटेटेड अबाउट इट्स एक्सिस बाय अ फोर्स ऑफ 20t minus 5t square Newton is applied tangentially. If the moment of inertia of the pulley about its axis is 10 kg per meter square, the number of rotations made by the pulley before its direction is reversed is. तो यहां पे पहले तो मेरा फोर्स है, उससे मैं निकालता हूं टॉर्क. सो टॉर्क इज फोर्स इनटू द डिस्टेंस, तो यहां पे डिस्टेंस को मल्टीप्लाई कर दो, सो योर टॉर्क बिकम्स 40t minus 10t square. This is my torque. Next thing I need is alpha, which is the angular velocity. Alpha is equal to torque divided by moment of inertia. So alpha is equal to tau by I, that is equal to this divided by I is 10 kg per meter square. So that makes it 4t minus t square. Okay. फिर मेरे को क्या चाहिए, मेरे को चाहिए ओमेगा, राइट. ओमेगा इज इक्वल टू alpha dt because alpha is d omega dt, so omega is equal to alpha dt. तो इंटीग्रेट करते हैं इसको. इंटीग्रेट जैसे ही करोगे ये तुम्हें देगा 2t स्क्वायर माइनस टी क्यूब बाई 3 प्लस एक प्रोपोर्शनिटी कांस्टेंट ऑफ इंटीग्रेशन आएगा विच यू कैन टेल ओमेगा इज 0 एट t इक्वल टू 0, सो इंटीग्रेशन कांस्टेंट भी 0 ही आएगा. सो आई हैव ओमेगा. आई वांट टू फाइंड एट व्हाट टाइम आई गेट द मैक्सिमम दिस. ठीक है, तो ये जो है एट दैट पॉइंट ओमेगा शुड बी 0, क्योंकि अगर वो मूव कर रहा है एट अ सर्टेन एंगुलर वेलोसिटी, स्पीड अप हो रहा है, स्लो डाउन कर रहा है सेकेंडरी, बट इफ इट इज टर्निंग इट इज स्लोइंग डाउन, इट विल स्टॉप, देन इट विल स्टार्ट टर्निंग द अदर वे. तो वो स्टॉप मतलब एंगुलर वेलोसिटी 0 हुआ. सो वी नीड टू फाइंड द टाइम वेयर दैट एंगुलर वेलोसिटी बिकम्स 0. सो इफ वी डू दैट वी गेट ओमेगा, दिस हैज टू बी इक्वल टू 0. सो 2t स्क्वायर minus t cube by 6 has to be equal to 0. So ये क्या देगा तुम्हें, t square if you take out you have sorry ये t cube by 3 है, this is t cube by 3, so you'll effectively be getting t is equal to, cross multiply, t is equal to 6 seconds. So at that time it starts turning back. The question अभी हम लोगों को पूछा है कि how many rotations does it make? So I need that theta, I need the angular displacement. So angular displacement का relation क्या होगा? Theta would be equal to integration of omega dt and the limits would be from 0 to 6 seconds. बस उतने duration में ही मेरे को चाहिए. So over here if I integrate that 2t square minus t cube by 3, I will be getting 2t cube by 3 minus t क्यूब बाई 3 का होगा t टू द पावर 4 डिवाइडेड बाई 12, और इसके लिमिट्स लगेंगे फ्रॉम 0 टू 6. तो डालते हैं, ये 0 वाला पार्ट तो भूल जाओ, वो तो एनीवे सिंस देयर ऑल t, सो दैट विल नॉट प्ले रोल ओवर हियर, वो हट जाएगा. यू वुड बी हैविंग, अगर मैं t क्यूब कॉमन ले लेता हूँ, t क्यूब मतलब हो गया 6 क्यूब इंटू 2 बाई 3 माइनस t by 12, t would be again 6, so 6 by 12, that is equal to half. So what do I get? I get 6 cube into, नीचे 3 और 2 का LCM लाएगा 6, this will go with factor of 2, so 4 minus this would go with 3, so 6 cube by 1 by 6, इसको हटाओ, square करो, this is 1, so that is equal to 36. This is my value of theta. But this is still not enough because the question says that I need to find the number of rotations. How do I find the number of rotations? The number of rotations n is equal to theta divided by 2 pi because each rotation takes a radiance of 2 pi over here. Theta का value 36 divided by 2 pi. अभी if I take pi value as 3, then it is 2 into 3 6, 36 by 6 would have given me 6. But because pi is a bit more than 6, you can tell that this value will be a little less than 6. Okay, because if it is a bit more than 6, then this fraction would be a little less than 6. So over here, if you look at the option, it would be option A, more than 3 but less than 6, because nothing else holds true for besides that. Okay, answer is A. That's right, Jaideep. I'm assuming you answered for this one only. Anyway, move on करते हैं. This says a moment of inertia of a uniform semicircular wire of mass m and radius r about an axis passing through its center of mass and perpendicular to its plane is mr square into 1 minus k by pi square. We need to find the value of k. We need to moment of inertia, semicircular wire, axis through its center of mass. Acha, first thing we need is where does the center of mass of a semicircular wire lie? हमें पता है कि if we have the complete circular wire, center of mass is at the center, but if it is a semicircular wire, then in that case, चलो x axis पे तो it will be at the center, but in the y axis it is raised by a distance of 2r by pi. Just a moment. it is raised by a distance of 2r by pi. ठीक है, ये रिमेंबर दिस हैज अ रिलेशन, सेंटर ऑफ मास ऑफ द सेमी सर्कुलर रिंग इज रेज्ड बाय 2r by pi. अब मेरे को क्या करना है, आई नो दैट थ्रू दिस द सेंटर ऑफ मास इज mr स्क्वायर, सोचना भी नहीं है, ओके, और रफली थ्रू दिस एक्चुअली इट इज mr square by 2 नहीं है, this is a disc or a wire, this is a wire, so it's just mr square. Since I'm shifting it parallel, the axis shift is parallel to the original axis, so it's just the parallel axis theorem, which means I dash is equal to I plus mr square, right? That is what you would think. But यहाँ पे parallel axis theorem में ये माइनस के साथ आएगा. क्यों माइनस के साथ आएगा? बिकॉज यूज योर कॉमन सेंस, यूज योर कॉमन सेंस, ठीक है. दिस इज 2r by pi. यस जयदीप, कॉमन सेंस क्या है? इस पॉइंट पे मोमेंट ऑफ इनर्शिया शुड बी ग्रेटर, क्योंकि किसी भी बॉडी के एज पे मोमेंट ऑफ इनर्शिया ज्यादा होता है, बिकॉज वहां पे सारा मास एक साइड पे हो जाता है. जैसे इफ यू टेक द एग्जांपल ऑफ ऐसी, अगर मैं इसको इस पॉइंट से, कंप्लीट रिंग है, इस पॉइंट से अगर मैं इस पॉइंट पे लेके आऊं एक्सिस को, मोमेंट ऑफ इनर्शिया विल इंक्रीज. व्हाई? बिकॉज नाउ मोस्ट ऑफ द मास इज ऑन वन साइड. तो जितना मास इम्बैलेंस्ड रहेगा ना, उतना मोमेंट ऑफ इनर्शिया ज्यादा होगा. सेंटर में मोमेंट ऑफ इनर्शिया ज्यादा इम्बैलेंस्ड नहीं है, तो वहां पे मोमेंट ऑफ इनर्शिया कम है. लेकिन जैसे ही तुम इस साइड आ गए, इम्बैलेंस हो गया, मोमेंट ऑफ इनर्शिया बढ़ जाएगा. अब समझो, इफ आई एम डीलिंग विद दिस सेंटर ऑफ मास, ठीक है, सेंटर ऑफ मास इस पॉइंट पे अगर मैं कंसीडर कर रहा हूं, तो वहां पे दिस थिंग इज एक्चुअली प्रिटी लेस. इस जगह पे वैल्यू कम, इस जगह पे वैल्यू कम होगा, यहां पे जब जाएंगे तब वैल्यू बढ़ जाएगा, राइट. सो दैट इज व्हाई ओवर हियर यू वुड बी हैविंग I minus mr square. So that is equal to original, the mass is mr square minus m into r. How much am I shifting it by? I'm shifting it by a factor of 2r by pi. So capital R पे रखते हैं, small r ही कर देते हैं, चलो इसको भी consider this a small r only. So it is 2r square, 2 नहीं 4 हो जाएगा because it's mr square, m into 4r square divided by pi square. So if you take mr square common, 1 minus 4 by pi square. So our correct answer is 4. ठीक है, is this clear to everyone? ये क्यों नेगेटिव हुआ? ठीक है, बिकॉज ओवर देयर द वैल्यू शुड बी लेस. यहां पे जो मोमेंट ऑफ इनर्शिया है वो कम होना चाहिए. ठीक है, चलो दैट्स नेक्स्ट. ओके, दैट्स इट, दैट वाज द लास्ट क्वेश्चन. तो ये वाला चैप्टर तो हो गया इसमें, बट आई एम स्टिल टेलिंग कीप प्रैक्टिसिंग मोर. आई डिड नॉट डू द वेरी जेनेरिक क्वेश्चंस. मैंने थोड़े ऑफबीट क्वेश्चंस भी कहीं कहीं पे उठा लिए हैं, बिकॉज जेनेरिक क्वेश्चंस यू वुड प्रैक्टिस वैसे ही. This is one of the most important parts. Focus on this section. You'll get lots of questions on this in multiple platforms. हमारे Telegram channel पे भी you'll get it. You'll find the link down below. So that's it. Tomorrow we'll be discussing on gravitation and properties of matter. As in properties of matter मतलब तुम्हारा वो भी हो जाएगा, क्या कहते हैं, elasticity, fluids. See in the Telegram channel the entire thing is there. If any of you are not over there in our Telegram channel, join it. It's just down below. You'll get all of these PDFs as well also over there. So anyway, thank you so much to everyone. Thank you especially Jaydeep, you've been there consistently answering all the questions. Good work. We'll be meeting again tomorrow, this time 6 to 7:30. अभी 7:30 around ही बज रहा है. 6 to 7:30 where we'll discuss, like I said, gravitation and the other parts. Thank you again. Let's wrap this up. Thank you so much. Catch you all in the next one.